Okay, problem number 4. We have a 3,500 pound weight being dangled on the end of two cables. One cable at a 40-degree angle, one cable at a 55-degree angle, and we want to find the tension in each of these cables. Now, this is 100% equivalent to the hanging hippo problem, which I explained in detail in the beginning of these in the beginning of this particular study guide video. So if you need a more detailed explanation than I'm going to give in this problem, go to that. It's like 15 minutes long, and I tried to be very in-depth. So this one will be quicker since I've already done that in great detail. So again, think about these two vectors, T1 and T2. These are forces, but they're going to break down into their vertical and horizontal components. Pulling in that direction, then remember we have a downward force of gravity on that hippo, pulling down with a force of 3,500 pounds. And in order to solve this problem, remember we can draw ourselves a force diagram. Sometimes that's helpful. We have our 3,500 pound force there. We've got then our two forces here, and I'm going to draw in the vertical and horizontal components of each. Now this isn't even remotely to scale, but that's totally fine. This angle on the left is 40 degrees. This angle on the right is 55 degrees. And I'm going to label this as we had it before, T1 and T2 for tension 1 and tension 2. So now we need to go ahead and write the horizontal and vertical components of these forces in terms of those tensions T1 and T2. And again, since I already explained it in the other video, I'm jumping straight to T1 cosine of 40, T2 cosine 55, and T1 sine of 40, and similarly T2 sine of 55. And again, if you don't know where that's coming from, you need to go watch the hippo video. Plus, it's got a really nice looking hippo that my roommate made for us. So, yeah, there's that. Okay, now remember, we need our horizontal forces to balance each other out because this weight is in equilibrium. So to represent that, we're going to get T1 cosine of 40 equals T2 cosine of 55. Let's go ahead and jump to where we're going to go with this. I'm going to solve this for one of my variables. So I'm going to get T1 equals T2 cosine 55 divided by cosine of 40. Let's write my second equation. Second equation is going to be to balance the vertical component of these forces. So for that, I'm going to need the sum T1 sine 40 plus T2 sine 55. That needs to equal the downward force of gravity on this weight, 3,500. And again, those are in pounds, unit of force. Okay, so now we need to take this value for T1, substitute it in right there. So we do that, we're going to get T2 cosine of 55 divided by cosine of 40 times the sine of 40 plus T2 sine 55 equals 3,500. All of that just from what we did right there. Gave myself a little more room on the screen. And now let's go ahead and factor out T2 so we can solve for it and get a value. So pull T2, that looks like a road. Pull T2 out of there, factor that out. What's left behind? Well, you have cosine of 55 times the sine of 40 divided by the cosine of 40 plus, factor out the T2 from that second term, you're left with sine of 55, and all of this is still equal to 3,500. So just like before in the hippo problem, get T2 by itself, by dividing by that whole mess right there. So T2 is going to equal 3,500 divided by, parentheses, cosine 55 sine 40 divided by cosine 40 plus sine 55. And a double parentheses at the end. And if you type that exactly like you see it there in your calculator, you should get that T2 equals, plugging that in, you should get 2,691.397 pounds for the tension in cable 2. Now to find the tension in cable 1, just solve back into the equation we already have solved for tension 1, and just substitute in. So T1 is going to equal T2, which is 2691.397 times the cosine of 55, all that divided by the cosine of 40. Plug that into your calculator. You should get the value 2,015.186 pounds for the tension in cable 1. That is, those are our two answers, and we are finished. Again, if that was too quick for you, didn't make sense, go watch the HIPAA video in depth.